Welcome to the lecture on Chevron cracks and reheat cracks. So, we are going to have the discussion about these two special type of cracks which occur in the either the weld metal zone sometimes or in the HHR zone. So, depending upon the type of cracks we will talk about these cracks. So, coming to first the Chevron cracks, and basically these cracks are the intergranular and transgranular cracks, and usually associated with basic SAW fluxes. So, we use these fluxes in the submerged arc welding processes, and also sometimes with the coated electrodes. So, there you have the chances of having these formation of such kind of cracks. So, why these cracks are also known as the staircase cracks or even the 45-degree cracks, because they are basically among the category of weld metal cracks, and they are known as 45-degree cracks also because their orientation is at 45 degree to the weld axis. Now, what happens that they are hot cracks and caused when metal is subjected to ductility deep cracking, as steel may lose ductility between certain temperature like 1200 to 1000 degrees centigrade. In that range, the steel will lose the ductility and it will be recovered when it is coming again to 800 degrees centigrade. So, what is happening when you have you are the weld specimen is or the region is undergoing that temperature range. So, basically what is happening that there will be segregation of the sulfur and phosphorus on the grain boundaries. So, that segregation, this segregation will be causing that intergranular type of cracks. Now, these cracks show the thermal facets by the oxide colors, and that shows that they are exposed to the high temperature. Now, if you try to look at these cracks, so what you see that this is how you see that this is how their orientation is looking like. So, on the top it is coming like this. So, they are basically at 45 degree to the weld axis. So, that is basically this type of cracks which is seen. So, in the weld metal, that is the indication of having these Chevron cracks. Now, these intergranular cracks, they are also joined by the transgranular cracks at low temperature by hydrogen cracking to. So, basically that way you get these Chevron cracks, and that is what is shown in this figure. Now, another theory which is talking about the Chevron cracks is that the cracking will be all due to the hydrogen embrittlement, and that will be taking place at the different temperature ranges. So, because of that these Chevron cracks are coming. Normally, Chevron crack which is observed, it is most commonly observed in relatively thick sections of carbon manganese steel plate, and that too when you are welding that with the high input high heat input welding processes. So, in those cases you are likely to have, so that is why we talked about these SAW processes. In that you are likely to have the formation of these Chevron cracks. Then the another crack which is observed, which is to be discussed today, is the reheat crack. Now this reheat crack, or it is also known as the PWST crack, that is post weld heat treatment crack, and as the name indicates that these cracks are because of the post weld heat treatment to which the weldment is subjected to. So, during that post weld heat treatment, these cracks are basically likely to come. So, reheat or the post weld heat treatment cracking are normally found in HZ zones and appear to be restricted to steels or weld metals containing at least two of the elements chromium, molybdenum, vanadium, and boron. So, normally if any of these two elements are there in the steel, so they are more likely to have the chances of having the reheat cracks. So, if you look at these elements, they are basically the strong carbide formers. So, basically we will have the discussion on that line about the occurrence of these kind of cracks. Now, they are normally found in the heavy sections and also in the coarse grained weld metal and parent steel. So, normally that is where they are found, like in the heavy sections also, and in the case of those weld metal where you have the coarse grain, or in the parent steel where you have the coarse grain formation. So, there it is more likely to have the the occurrence of these type of cracks. Now, it is a typical problem in the corrosion and heat resisting low alloy steels, basically that is your ferritic steels, which contain that chromium, molybdenum, and even sometimes the vanadium also. So, these are the ferritic steels. Now, normally what we do, normally we are providing these alloying elements for the increased corrosion resistance to the steel. Okay, then and also mostly they are used for the nuclear applications. So, they are also their typical use is at those places. Now, for that that typically the steel which is if you talk about these ferritic steels, so they are basically half chromium, half moly, and 1/4 vanadium, that kind of steel, or half chromium, moly, vanadium steels. So, that these steels basically are they are the one which are that is used for the corrosion resistance. Now, what happens that because of their presence, the susceptibility to these type of heat cracking is there. So, because of the presence of certain alloying elements, these they are susceptible to the reheat cracking. So, for that there has been a parameter, that is your reheat crack susceptibility. So, that is RCS. So, this reheat crack susceptibility, this is this shows the relationship. So, reheat crack susceptibility. So, so you will have the effect of alloying element on the reheat crack susceptibility, RCS, and that has been given by the authors. So, one author, that is Nakamura. So, he has given the certain expression, that is RCS will be percentage chromium plus 3.3% molybdenum plus 8.1% vanadium minus 2. So, that is by Nakamura, and similarly by Ito. So, Ito and Nakamura both have given. So, using these Ito's relation, this is RCS is percentage chromium plus percentage copper plus 2% molybdenum plus 10% vanadium plus 7% niobium and plus 5% titanium and then minus 2. So, this way you will have the if you look at most of the elements which are used, they are the strong carbide formers. So, basically these these elements, they will be giving you these reheat crack susceptibility, and if the if RCS is found to be more than equal to 0, in that case the steel is susceptible to reheat cracking. So, the steel is susceptible to reheat cracking. So, that is what the condition is there for the existence of the reheat cracking. So, what has happening basically. So, if you will come further. So, what happens that when we are doing these post weld heat treatment to the to a higher temperature. So, we normally do in the range of 550 to 650 degrees centigrade. So, so that basically will be quickly relieving these releasing the elastic stresses. So, they are relaxed quickly, but then there will be carbide precipitation that will be occurring within the HZ grains in the corrosion resistant low alloy steels, which is containing the chromium, molybdenum or vanadium as the alloying elements. And as we know that these alloying elements are strong carbide forming elements. So, so there will be carbide precipitation also. So, that that can occur in these corrosion and heat resistant low alloy steels when you are doing the stress relieving treatment. So, so these carbide precipitation which occurs, that that will be that will be making the grains stronger. So, the interior of the grains will be relatively becoming stronger, but then the grain boundary will be weaker. So, your interior will be stronger than the grain boundaries. So, when the the residual stresses are relaxing, then what is happening that the rupture or the failure that may occur along the grain boundaries, and that is how you have the formation of the grain boundary intergranular cracking in those conditions. So, basically the cracks will be occurring along the austenite grain boundaries or in the HZ of the transformable steels, and also it will be along the grains along the other grain boundaries in the case of the austenitic steels. So, that kind of cracking can be observed when you do these post weld heat treatment. So, so if you look at the reheat crack which is taking place, so you have the different steps which is going on how these reheat cracks are coming up. So, initially you will have the nucleation cavities on the grain facets that will be appearing, and normally it will be appearing on the grain facets as well as on the triple junction. So, that is the first stage. The next stage will be that all these individual cavities which you are getting formed, so their growth will be there. So, that will be the next step, that there will be growth of these formed nucleation cavities, and that will lead to the formation of one grain facet in length. So, of that length basically it will become. So, once it will grow, and then you will have the interlinking of these grain facets. So, so grain facet cracks which has occurred. So, once they are interlinked, then you will have the crack that will be propagating. So, that length will be having several grain dimension. So, grain diameter long, and that will lead to the rapid fracture of the weld. So, that way welded specimen. So, this way in that different steps you have these failure taking place. Now, we talk about the reheat crack tendency. So, the tendency basically will be affected or accentuated by many factors. So, these factors are like if you have the structure having the poor ductility. So, in those cases you will have the chances of having the reheat cracking. So, if you suppose have the upper banetic type of structure, and so it will have the more susceptibility towards the reheat cracking. So because at elevated temperature you will have the embrittlement that will be taking place. So, so that is why the structure with poor ductility is important. Then coarse grain, anyway coarse grain is more susceptible to the reheat cracking as compared to the finer grains. Then you have high heat input processes, whichever has the specific high heat input processes are there, like electroslag welding or submerged arc welding processes. They basically are so the joints which are made by these processes, they are more susceptible to the reheat cracking of the specimen. Then it is also many a times it is affected by the section size also. So, many a times it is more for the higher thick sections, more than say 50 mm the section thickness is there. So, in that case it will be more. Then the next is the preheating. So, it will be normally if you do the preheating, then it will increase the grain size, and once the grain size is increased, in that case it will again be more susceptible towards the reheat cracking. Apart from that, you will have the high level of residual strains if they are there. So, then also you have the and also some degree of traxility there. So, in those cases you have more chances of having these the reheat cracking and all. Then further, so what we see that these factors they are important ones to see that your cracking tendency becomes more or less. So, accordingly you can have the proper you can have the proper way to control these tendency to have the reheat cracking. Now, the next point is that the problem of reheat cracking. So, this problem basically is also occurring in the nickel based steels. So, in nickel based alloys and also in case of certain steels. So, that is the alloys, low alloy steels. So, what is happening that in the case of nickel based alloys and also the austenitic stainless steels, we see the occurrence of these reheat cracking, and among the low alloy steels if you look at, so you will have some grades which are very much susceptible to this reheat cracking. So, in a general rule, if you talk about the post weld heat treatment of carbon manganese steels, then that basically will be improving the fracture toughness, and it will be although it will have the low impact toughness, basically whenever you deal with the high specific heat input processes. So, these low alloy steels which we use normally, a typical low alloy steel which has the nickel percentage of say among low alloy steel, if the nickel percentage is suppose 0.7, chromium is 0.4, and and molybdenum is this 0.6. So, they are normally used in the nuclear pressure vessels, and they are very much known to these reheat cracking. So, crack will be occurring in the grain growth zone, or either as the longitudinal macro cracks, or the micro crack network. So, that way these reheat cracks are observed in such case of steels, which is the low alloy steel which is used in the nuclear pressure vessels. Now, what is happening that many a times you have the observation of these reheat cracks in a different manner. So, we term it as the strain edge cracking also in the case of the when we do the post weld heat treatment of heat treatable nickel based alloys. So, what we do normally is that we are solutionizing first in those cases, and and then so in that case there are two things which is happening. One is aging and another is the stress relieving. So, what will be happening in that case? So in this case what we do is that when we use these heat treatable, these nickel based alloys during the solutionizing treatment. So, to have the more strength, what we do is we normally solutionize and then we age harden. So, so in that case it gets aged also, that is aged. So, what is happening that when we do the solutionizing, in that case the stresses are relieved. However, the aging also occurs in the weldment, and so the aging temperature range is normally lower than the the solutionization temperature. So, the aging is occurring, and before that so that is occurring before the residual stresses are relieved. So, what is happening that before that residual stresses are relieved, and since the aging occurs, so that results into the cracks. So, that often results into the crack during that post weld heat treatment, and this crack which is occurring during that post weld heat treatment, that is known as the strain edge cracking, because this is occurring in a highly restrained weldments, and they are heated in the range through which that aging is occurring. That is why we call it as a strain edge cracking. And if you look at the cycle, so for the where the reheat cracking may occur for these nickel based alloys. So, that cycle basically if you look at these nickel based alloys, so this is your post weld heat treatment, so this is welding of nickel based alloy. This is heat treatable. So, this is your temperature and this is the time. So, you do the welding here, and then it is getting cooled, and then what you do is once it is, so you are so you will have a range, and then you are heating, and this is your solutionizing during this time, and then you are coming into this this time, and this is your aging which is occurring, and then it is following like this. So, this is your basically aging temperature range. So, this is becoming your aging temperature range. So, while heating basically this is your temperature at which you have to go. So, this is your solutionizing temperature, and before that basically this it has to this aging is done. So, and then so you will have the residual stress will be there. So, that is so because of the residual stress plus aging, you will have the you have the residual stresses which are relieved once you go into that region. So, before that the residual stresses, and because of that aging you will have the crack formation. So that is so in this case here you have the residual stresses. So, therefore, that relieving that you are going. So, this way because of this range through which it is passing, you have the chance of crack that is formed. Now, if you talk about the reheat cracking. So, now reheat cracking in the nickel based alloys is because of the the result of low ductility in HAZ accompanied by high strains in that region. And in those cases many a times the practice is that you over age before the welding. So, that gives even the sometimes the better results in those cases. Although the overaging if you do that may not be good in the HAZ zone, but then it has been seen that before the welding you can go for the overage. So that that may be advantageous. So, HAZ of a weldment in a heat treatable this and nickel based alloy after the post weld heat treatment, that responds in a different way. Now, if you look at the avoidance of these reheating cracking in the steel. So, there are certainly some steps which can be followed, so that way your stress relaxation you can have the avoiding of the reheat cracking. So, this is basically the example of these reheat cracks which you can see here. This is how the reheat crack looks like. So, if you see that if you try to see that if you try to avoid these formation of reheat cracks. So, there are certain steps by which you can avoid these reheat cracks, and these are that you should have the limited vanadium content in the thick sections, and then you can have the design to have the minimum restraint, and further you can have you can have the higher preheat temperature. So, so that these are the way to avoid these reheat cracking in the steel welds. Now, there is one more thing which is important to know under while we discuss about the reheat cracking is the C curves for the crack susceptibility. So, if you talk about the crack susceptibility, so there is a crack susceptibility C curve. So, if you see the for materials like a wasp alloy or inconel. So, what has been seen that you have so this will be temperature and this will be time. So, this will be on the log scale. So, it will be 1, 10, 1, 10, 2, 10, 3. So, what is seen is that this curve is found, and depending upon, because what is happening that in that case you have no cracks on this side, So, this is your crack susceptibility C curve. So, that is known as so how much it will be susceptible to the crack, and this is your and this is for wasp alloy, and if you go for the alloy 718. So, for alloy 718 it goes like this. So, so you have the improved welding, improved weldability in these cases, and you have the HAZ cracks which is likely to form here. So, this curve indicates that at the lower temperature range. So, this is about 1200 Fahrenheit. So, this is in Fahrenheit, degree Fahrenheit. So, 1200 1400 1600 and then 1800. So, what this curve indicates that at the lower temperature range, what you see that this is going asymptotically. So, you for infinite time it may go. So, that way there is no chance of these crack formation, whereas if you increase the temperature, in that case you have certainly the chances of these HAZ cracks which is at lesser time. So, this way these these reheat cracks susceptibility is basically represented in terms of these crack susceptibility C curves. So, these that is approaching higher temperature limit also, one limit is there. So, that way you must understand that there are conditions because of which these materials are susceptible, more susceptible to the reheat cracks. There are many factors, that is what we have studied, and mostly because of the presence of these elements which are there, which are the strong carbide formers, carbide forming elements, and since they are present. So, that leads to the formation of these reheat cracks in the case of the steels, whereas as we see in these cases, in the case of nickel based alloys or so, you have the other factors apart from those factors. You have factors like restraint factor, and you have factor like the a limiting amount of certain material or so. So, this is something we have discussed about the reheat cracks, and we also talked about the chevron cracks. We will talk about few other types of cracks also in our coming lectures. Thank you very much.